All right, we are going on an absolutely incredible journey today. We're going to start with something we all kind of know, the code of life, evolution. And we're going to follow that thread all the way to this mind-bending idea that reality itself might just be a giant cosmic computer. Seriously, we're going from biohacking all the way to the nature of what's even real. So let's just dive right in.
Okay, so let's get our bearings by starting at the beginning, with the very engine that drives all of life, evolution. It's the foundational force, the process that builds all the insane biological complexity we see around us, from a single cell all the way up to, well, us.
So what is evolution really, when you strip it all down? I think the evolutionary biologist Sean B. Carroll just nails it with this quote: "Evolution is change over time." That's it. That's the whole thing in 4 words. But as you're about to see, that little phrase, over time, well, that's where things get absolutely staggering.
And look, when we say time, we're not talking about a few generations. We're talking about timescales that are almost impossible to wrap your head around. For just noticeable changes to pop up, you're looking at 100,000 years. For distinct populations to form, try 500,000. And for 2 groups to actually become entirely separate species, you're talking 1,000,000 years, or probably even more. It's not some clean, sudden event. It's a slow, gradual, and, as Carroll says, a pretty sloppy process.
So, if evolution is this incredibly slow, sloppy process, how does it build anything so complex? Well, now we get to pop the hood and look at the how, the actual genetic toolkit that evolution has been using all this time.
And this right here, this is a massive shift in how we understand evolution. The old idea was pretty straightforward. If you want a new trait, like wings or eyeballs, you need a brand new gene created from scratch. But the modern view? It completely flips the script. Turns out evolution almost never invents from scratch. It's a master tinkerer, a genius at repurposing old, ancient genes and just using them in brand new, creative ways.
The best way to think about it is like a universal set of Lego bricks. Get this, the exact same gene that tells a fruit fly how to build its eye is at work building your eye. The genes that contain the instructions for build a limb get repurposed to grow those crazy, elaborate horns on a beetle. That same limb-building program is literally copied and pasted onto a butterfly's wing to create its colorful spots. So you see, the big takeaway here isn't what genes you have, it's all about how you wire them together.
And this idea, right, the idea of wiring genes together, it naturally leads to a really profound question. If life's code is this flexible, this modular, what's to stop us from learning how to edit it ourselves? Can we become the programmers of life's software?
So, let's just ask it directly. If life really is a toolkit, just a box of programmable Lego bricks with instructions, can we start building with it? And this isn't science fiction anymore. This is the exact question that's driving the unbelievable work of biologist Michael Liven.
And his team's answer to that question is a resounding yes. Everybody, meet the xenobots. These are the world's first ever living, programmable organisms. You could call them biobots. But here's the crazy part. They're not made of silicon and steel. They're built entirely from the skin cells of a frog.
So what happens is you take these frog cells, you put them in a dish, and something just incredible happens. They don't just sit there. They actually self-assemble into brand new forms. They start using these tiny hairs on their surface to swim around and navigate. They work together in groups, in swarms. And here's the part that just blows my mind. They can replicate. They can literally find other loose cells in the dish, gather them up, and build new xenobots. Now remember, none of this was in their original genetic programming. Their only job was to be frog skin.
So how is this even possible? Well, Michael Liven calls it a multi-scale competency architecture, which, yeah, is a mouthful. But what it really means is that intelligence isn't just something that happens in the brain. It's, as he says, baked in all the way down. Every single cell in your body is a tiny problem-solving agent. And when you free them from their normal job of building a frog, their own collective intelligence bubbles up to build something totally new.
Okay, this discovery has some seriously profound implications. I mean, if a bunch of skin cells can reprogram themselves to solve new problems, it suggests life isn't just matter, it's an information processing system. So now, let's take that idea and just scale it all the way up. What if this principle of intelligence baked in doesn't just apply to biology, but to the entire cosmos?
And that brings us to this speculative but really fascinating idea called informational ledger theory, or ILT for short. And it proposes something radical, that the universe isn't fundamentally made of stuff like matter and energy. Instead, it is a self-organizing computational system. Everything we perceive as physical reality
It's just the rendered output of a much deeper calculation. It's the screen, not the computer itself.
So how would that even begin? Well, this gives us an idea. Forget the Big Bang of matter. Picture a cosmic computer booting up. It starts in what some theorists call the rulad, this chaotic soup of every possible rule for a universe. And out of that chaos, tiny computational nodes, let's call them chiplets, start to form and process information. And as they do their work, they create a permanent record of every calculation, a kind of ledger. And according to this theory, that ledger is what we experience as spacetime.
Yeah, the core idea is right there on the screen. Reality functions as an append-only informational ledger. It means every single thing that happens, every interaction from a star exploding to you listening to my voice, is a calculation that gets permanently recorded, added to the list. The universe, at its most basic level, is a system for processing and storing information.
So, if we're living inside a giant, self-organizing computer, an information processor, where does that leave us? What is the role of something as strange and wonderful as consciousness in this cosmic operating system? Okay, let's connect the two really big, mind-bending ideas we've just covered. We saw with the Xenobots that individual cells are tiny problem-solving agents. And with ILOUT, we've entertained the idea that the universe itself might be a kind of global intelligence. So we have intelligence from the absolute smallest scale all the way to the largest imaginable scale.
Now, informational ledger theory offers a pretty radical new take on what consciousness is. It's not some random fluke, not some weird byproduct of evolution. The theory proposes that consciousness is the universe successfully generating local hardware to process its own ledger with maximum efficiency. In other words, we are the universe becoming self-aware, building little biological computers, our brains, to better understand itself.
And that leaves us right here, with one final awe-inspiring question. If our cells are intelligent agents navigating their tiny worlds, and the entire universe is a vast computation processing information, then what is our role in all of this? Are we just users running on the system? Or are we something more? Are we actually part of the code itself, actively helping to write the next line of reality?